Hi, it's Mrs. Blankenbeckler, and I'm here to go over lesson 8.03. We're going to talk about solving quadratics. When you solve a quadratic, if you did this last year, this should be a nice quick little review. But as always, I want to approach it from two different ways. I want to look at it as a graphical approach and as an algebraic approach. Okay, let me do the graphical first because I think that is by far the easiest way to look at this. Okay, graphical approach, finding or solving quadratics, is very simply looking at where your quadratic crosses the x-axis. So here's your x-axis, here's your y-axis. And what is a quadratic? A quadratic is a parabola. So if my parabola crosses at -3, +1, and let's just say it faces down. We know that A is negative because it faces down, but we don't even care about that so much as what are the solutions. The solutions are simply where the graph crosses the x-axis. So that would be -3 and +1 are the two solutions. Simple as that. Okay, this one had two solutions. What are the other possible ways that a quadratic can have solutions? Well, a quadratic could have one solution. Well, what would that look like? That means the vertex would have to lie on the x-axis somewhere. So it may look like this, where your parabola comes down and crosses the x or touches the x-axis at the vertex. This one has just one solution. So you can have one solution or two solutions. One solution where the vertex touches, two solutions where the parabola is either above it or below it. If it faces up, it might be below and cross twice. There's one more option, and that's where it doesn't cross at all. So you could possibly have a quadratic that faced up and the vertex was above the x-axis, or a quadratic where it faces down and the vertex falls below the x-axis. So this one wouldn't have any real solutions. It would have imaginary solutions, but no real solutions. So there's the graphical approach to looking at roots or solutions to quadratics. Now we're going to look at the second way, which is algebraic. Algebraic, all you have to do is remember how to factor. If you can factor, you can solve these. Okay, and that's what we're focusing on in this lesson. It's just the factorable ones. There are 3 problems in the LMS, and I'm going to go through those factoring problems. If you need more practice, you can go to the Khan Academy website, and I'm going to have that for you guys on the calendar, so look for that. And also you can go back to the lessons in Unit 5. Those are all the factoring units. I'm going to open that up for you guys so you can look through that if you need to. But let's go over factoring for a minute. Okay, the first one that's in the LMS is x squared equals 6x plus 27. Okay, let's look at this one. How would you find the solutions to the quadratic? Well, we need to get it so we can factor it. So we need to get it in descending order. So that's step 1. Let's get it in descending order. X squared comes first. I'm going to bring the x to the first power over by subtracting it. So minus 6x. Bring the 27 over by subtracting it. Minus 27. And what's left over here? Nothing. 0. Okay? So I've got it in descending order. Now I need to factor it. You ask yourself what multiplies to 27 that has a difference of 6. What multiplies to 27 that has a difference of 6? And the answer is, well, write your factors. Is it 1 and 27? No, the difference is 26. 2 doesn't go into 27, but 3 does. 3 times 9. Well, 3 times 9 is 27. The difference is 6, so it's got to be a 3 and a 9. So x, because x squared factors into x times x. 27 factors into the 9 and the 3. Now we have to concentrate on the signs. I need to get a -6. So how do I do that? -9, +3, combined to the -6. -9, +3. So now I have it factored. Once I get it factored, I have to solve it. Well, remember, we're multiplying two things, this times this, or a binomial times a binomial to get 0. What's the only way that you can multiply to get a 0? One of these has to be 0. So when is x minus 9 0? When x is +9. When is x plus 3 equal to 0? When x is -3. So the two solutions are 9 and -3. So there's the first one. Okay, that was one with a lead coefficient of 1, so it was fairly easy. So my method is to ask what multiplies to the constant term, and I always look at the sign. Does it add or subtract to this number? In other words, this one would subtract to 6. What two numbers subtract to 6? And it ended up being 9 and 3. Now let's look at one that may not be quite so easy because the lead coefficient is not 1. So let's look at this one. 4x squared plus 2x minus 30 equal 0. Okay, one thing you notice about this one is it has a greatest common factor. The greatest common factor is 2. So I'm going to factor a 2 out. Sometimes you have to take a 2x out. Sometimes you take a 5 out. But this one has a common factor. So you always want to check for your GCF first. So take a 2 out. I'm left with 2x squared plus x minus 15. Still equal to 0. Now, notice my lead coefficient in front of my x squared term, my a, is not 1 anymore. It's 2. So I'm going to bring the 2 down. It just sits out on the front porch. And now I'm going to factor this binomial into two binomials. Remember, factoring and foiling are just opposite each other. Just like adding and subtracting, multiplying and dividing. Well, foiling is multiplying, factoring is dividing. So we're just dividing this polynomial up into its two factors. Okay, so we know this has got to be a 2 and an x, because that is the only way that 2x squared is going to factor. 2 times 1 and x times x. So that part's pretty easy. Now, we have a couple choices back here. 15 is 15 times 1 or 3 times 5. Okay, so we got 15 times 1 or 3 times 5. Because this number is fairly small, I'm going with the two smaller numbers because they're probably closer together. So I'm going to play around with this. Well, if I put a 5 here and a 3 here, that's going to give me 3 and 10. Those don't have a difference of 1, do they? So let's switch the positions and let's try the 3 here and the 5 here. 6 and 5. They have a difference of 1, don't they? Okay, since they have to have a difference of 1, there it is. Now I need to make this so these add to a positive 1. Well, that means this has to be a positive 6 and a negative 5 when I FOIL it, right? Because I'm checking my outer and my inner to see how I'm going to get the positive 1. And there we go. So that's how it factors, but I'm not done yet. Remember, I'm solving. So I got to set each factor equal to 0. Well, the first one's not quite so easy. I can't just look at it and go, I know exactly what it is, unless you're really good with fractions. But you're going to set it equal to 0. So you add 5, and then you divide by 2, and you get 5 halves. So that's my first answer, positive 5 halves. Over here, this one should be so easy, negative 30, right? So when is x plus 3 equal to 0? When x is negative 3. So my two solutions are 5 halves and negative 3. Okay, that's where we're stopping this first part. I've got one more problem to show you, And then I'm going to go over some problems for the mid-unit quiz. So watch part 2 in just a minute.